Hi, my name is Kira Van Winkle, and I'm a middle school science teacher in Iowa. If you're watching this video, it means that your class recently started a new unit, but you were not in class for all or part of this first lesson. Before I begin walking you through the first lesson, I'd like for you to gather a few supplies. You're going to need your science notebook, and if that's not available, maybe grab a couple pieces of blank paper. You'll also need a writing utensil. There will be some opportunities for us to walk through some of the activities and discussions that took place while you were absent, so make sure you have those materials ready. If you need a moment to gather your materials, just press pause. When you're ready to begin, press play. Our new unit starts off looking at weather events that are a little bit perplexing. I'd like to share a couple of videos with you, but before I do, please find a new page in your notebook or a blank sheet of paper and create a T-chart like the one pictured on this slide. We're going to watch the videos together, and then I'll give you some time to jot down things you notice and wonder from the video. If you need more time between videos, feel free to pause as needed and restart when you're ready for the next clip. I'll give you a second to record this T-chart in your notebook. Your heading should say Exploring an Outdoor Phenomenon, and then you should have a T-chart, and on the left side, write Notice, and on the right side, write Wonder. Okay, we're going to start by watching our first clip. This first clip was recorded on April 7th, 2013 in Fort Scott, Kansas. Please watch the video with me, jotting down your notices and wonders as you watch. If you need more time when the video is over, you can press pause and finish your recordings. If you need more time to finish your thoughts, just press pause until you're ready to continue. I find this video to be really interesting because where I'm from in Iowa, this sort of thing happens, but not very often. And I'm wondering if you've had any experiences like this where you're from. Be sure when you get back to class to check in with your classmates to discuss whether or not others have experienced this sort of thing as well. I've got another video from a different time and place that produced different sized pieces of hail than this one did. The second video clip was recorded on October 5th, 2010 in Phoenix, Arizona.
Well, I figured it would. I said I'm not surprised there aren't more windows busted. That was amazing.
That video is a lot more intense. It looks like that hail was more of like the golf ball size hail. Take a minute, note in your notice and wonder chart what you noticed and wondered, and also be sure to say that this was from video 2. If you need a moment to finish your noticings and wonderings, just pause here and press play when you're ready to continue. All right, this last video is a time-lapse video from before, during, and after a hailstorm that produced smaller hail than the other 2 videos. This video was recorded on June 10th, 2013 in Winnipeg, Manitoba, Canada. It's sped up 60 times, so each second in the video is equal to 1 minute of real time. So since the video is 99 seconds long, it represents 99 minutes or an hour and 39 minutes of real time. I'm going to show you this video again. Record your notices and wonders in your T-chart. If you need more time, press pause on the video and then press play when you're ready to continue. Okay. Again, if you need more time to record your thoughts, press pause. Please be sure to mark that these noticings and wonderings are coming from video clip 3. So one thing that I noticed about the second video in particular is that it was both raining and hailing. Do you know of a word that we could use to refer to rain or hail or even snow or sleet? We're going to use the term precipitation to refer to any liquid or solid forms of water that fall from the sky to the ground. When you return to class, you'll notice that the word precipitation has been added to your word wall. Your teacher may also want you to add this to your notebook, so be sure to check in with your teacher when you return to class. Here's a list of notices and wonders that other students had when they watched the videos that we just watched. Take a look at your list and compare it to these ideas. As you look, place a star or an asterisk next to the ideas on your list that are similar to what you see here. Pause the video here if you need more time to compare. Now that we have some notices and wonders written down, let's use those to develop a model of what we saw happening. We're going to create our model using 3 points in time. So before the event, during the event, and after the precipitation event. You can either access this handout using the bit.ly link shown on this slide, or you can just create your own in your notebook. Use the boxes to show what is happening both above and around the area where the precipitation fell. The box on the left should show above and around the area before the event. The middle box should show above and around the area during the event. And the box on the right should show the area above and around the event where it occurred after the event. Your model should not only show what happened, but also try to explain why it happened. Scientists use symbols and arrows and pictures and words to describe why their models help visualize their thinking, and it helps to communicate their ideas to themselves and to others. So take a few minutes to develop your initial model. I'm going to have you pause the video here while you work on that, and when you're ready to continue, just press play. So one of the things that I noticed when I watched the weather events and the video clips is that there was both liquid and solid water falling from the sky. And I also noticed that there were changes happening in the winds and the clouds overhead. And those were two important parts of the systems that were modeled and explained in the CUP unit too, if you remember. And I remember that when we did that unit, we came up with ways to represent matter and energy in those systems. So let's take a minute to just review that. And I'm wondering if maybe those representations could be helpful to us in this unit as well. So find a new space in your notebook and jot down your responses to the questions that are shown on this slide. How did we represent the particles that make up different states of matter in a gas, a liquid, and a solid? And then how did we represent the different ways that energy can be transferred into and out of a system like a cup with liquid in it? So I'm going to have you take a moment and jot down your ideas in your notebook. So pause the video, jot down your ideas, and when you're ready to continue, press play. And again, we're answering these two questions. So how did we represent the particles of different states of matter, solid, liquid, and gas? And then how did we represent the ways that energy can be transferred into and out of that system? So take a moment, jot those ideas down, and pause the video. So here's a quick review from the CUP unit of the ways that we represented different states of matter and energy in our CUP systems. And these might be similar to some of the things that you wrote down as you're reviewing in your brain. So if you look at this slide, we're showing that the particles in a gas like air are spread far apart, and the particles in a solid and a liquid are closer together, solid being even more closely together than a liquid. And then we also saw that energy can be transferred through collisions between neighboring particles, and that was called conduction, if you remember. So when energy gets transferred from one particle, it bumps into another particle and transfers some of that energy to the next particle. We also remember from that CUP unit that energy can enter a system when matter absorbs light shining on it, and that's called radiation. And we also know that the particles of a substance move faster when they have a higher temperature, and they're going to move slower when they have a lower temperature. So warmer particles move fast and cooler particles move slower. So let's try to use those ideas about particles and energy to represent what we think is happening in the air and water above and around where the precipitation event occurred. So you're going to need your initial model again that you just made. And then I would also like for you to take a look at this handout. So you can look on this slide, or you can use the bit.ly link that is on the bottom of this slide as well. And I want you to look at, on your initial model, look at the middle frame. So we're looking at what's happening during that event. Okay. So identify like 3 places in that frame. So I'm looking at the middle frame, and I'm going to identify 3 places where I think there were important changes happening at the particle level in the air or water above. Okay. And then you're going to add a small circle. So you're just going to write a letter A and circle it, or a letter B and circle it, or a letter C to those parts of the model. So where are we seeing changes in the particle level of air or water? And then using the second handout with the circles, you're going to represent what was happening at the particle level. So circle A all the way on the left is going to represent that place in your middle frame that represented A. Does that make sense? So what you're going to do is, using the second handout with the circles, show us what's happening at the particle level. So you might show us how those particles were arranged. You might also show us how energy is moving through that part of the middle frame. So imagine like those circles are zoom in lenses, and you can see how those particles look and act. So add a key if you need it, similar to the slide before this. Just pause the video here and add these pieces of information to your initial model and to your second handout, and then press play when you're ready to continue. Okay, so now that you've represented the particles in the model, go back to your initial model and use like a different color or type of writing utensil. So if you used pen before, use pencil now, to mark places where you think energy was getting transferred into, through, or out of the system. Okay, so again, we made a particle model of what was happening at spaces A, B, and C in that middle frame, and now we're adding another color or another type of writing utensil to show the energy transfer in that middle frame. So go ahead and press pause again, and then when you're ready to continue, press play. Okay, so we've now finished day 1 of our first lesson of the new unit. So if you only missed day 1, you can stop the video now. You're going to need to make sure that you keep the models that you developed safe and handy so that you can give those back to your teacher when you go back to class. If you missed the second day of the lesson, you can continue watching this video lesson. So let's begin day 2 of our first lesson. You're going to need the same materials as were needed in day 1. So either your notebook or some blank paper. You'll need a writing utensil, and then it will probably be helpful for you to have your noticings and wonderings and your initial model handouts from day 1. If you need time to gather those materials, just pause here and press play when you're ready to continue. Okay, so at the end of day 1, you revised your initial model to include information about particle level changes during the event and energy transfer during the event. So your classmates, in your absence, are going to be comparing models using a gallery walk, and then they're going to use those observations to create a classroom consensus model. And just a reminder, a classroom consensus model is a record of what everyone in the class seems to agree on, as well as areas where maybe there was some uncertainty or we had some competing ideas. So you're going to want to make sure that you look at your class's consensus model when you return to class. And then take out your initial model and particle level changes sheets from day 1. And we're going to use those to compare and contrast your ideas with the model on the next slide. So I'm going to show you a sample model. This one's probably different than what your class developed. So again, make sure that you go back to class and take a look at your class consensus model. But I'm going to have you take a look at some ideas that you had on your paper and compare it to the model on the next slide. So this slide shows an example of a class consensus model, and it's, again, probably different. Take out your initial model and take a few minutes to observe this model. In what ways is this model similar to what you made, and how is this model different? So I'd like for you in your notebook to just jot down some similarities and differences that you see. So that might be best if we make a T-chart in your notebook. So make a T-chart, and on the left-hand side, write similarities, and on the right-hand side, write differences. And then I would like for you to jot down what you see as different about and similar about this consensus model compared to your model that you developed in day 1. Press pause while you work on that, and then press play when you're ready to continue. Okay, so now that we've created a model to visualize our thinking and we've compared that to a sample consensus model from another class, let's try to capture some of the questions that we have about what's happening in this type of phenomenon. So take a minute again to look over your models and your notices and wonders, and then your list of similarities and differences, and make a list of questions that we could investigate in class together that would help us figure out what's happening to cause the phenomena that we saw in the video clips of the hail storms falling from the sky. This could be about the hail phenomena specifically, or it could be about similar phenomena. So maybe you don't experience hailstorms where you're from, but maybe there are other types of storms that you also have questions about that you think could apply to this hail phenomenon. So go ahead and ask questions about those if you have them. You could also ask questions about the sky or the ground or even the states of matter that we've been discussing as well. So solid, liquids, and gases. Anything that you wonder about that could help us figure out our hail phenomenon is totally fair game. So pause the video now to record in your notebook several questions that you have. You're going to need to share these questions with your teacher and your classmates when you return. So make sure to keep a list in your notebook. Go ahead and pause the video here as you create your list of questions. Make sure you number those questions in your notebook as well, and then press play when you're ready to continue. Okay, before we finish up for the day, I would like for you to find another space in your notebook, maybe below your questions or on a new page, and add the title Related Phenomena at the top. Okay, so you're going to use the instructions on this slide to help you identify other phenomena that are similar to the hail events that we saw in those video clips. So in your notebook, under related phenomena, you could describe some times when you've seen a lot of precipitation fall in one place in a relatively short period of time. So our hail videos, it didn't seem like the hailstorm lasted that long. So that would be kind of like that. So a lot of precipitation in a short period of time. And then I'd also like you to think about some other events where maybe you've seen a lot of precipitation fall continuously in one place over a really long period of time. So that could be like several hours, or it could even be days. You'll need to share those with your class when you get back as well. So take a few minutes and record your related phenomena here. And then you'll have to share those again when you get back to class. When you have that completed, you have finished day 2 of lesson 1 for this new unit. We're going to begin day 3 by reviewing and adding 2 questions for our driving question board. So you'll need to have those driving questions written down and numbered, and then also make sure that you have your related phenomena available for day 3. If you missed the 3rd day of the lesson in class, you can continue watching the video now. Or if you did not miss day 3 of lesson 1, you can go ahead and press stop here. All right, we are moving on to day 3. Okay, so for today's lesson, you are going to need similar materials to days 1 and day 2, where you had to have your notebook or blank sheets of paper available and also a writing utensil. You're also going to want your list of questions and your list of related phenomena for today's lesson. To begin this lesson, your classmates will have shared out their related phenomena, and because you're not in class, I'm going to show you an example of another class's related phenomena, and let's see if any of yours look similar. Do you see any similarities or differences in this list compared to your own? As you look at this list and your list as well, think about whether or not any of the same mechanisms and interactions that cause hailstorms could cause other precipitation events. So can we use what we learn about hailstorms to help explain any of these other scenarios? And then I'd like for you to choose one of the related phenomena from this list or from your list and develop another question and add that to your driving questions from day 2 that we can investigate to help us figure out. So take a minute, pause, think about a question about one of these phenomena or something from your list of related phenomena, and add that to your driving questions list. Pause here and press play when you're ready to continue. Okay, we're going to take a couple more minutes to think about the hail events that we watched in addition to those other phenomena from the previous slide. I'd like you to push yourself to come up with at least one more question and add it to your list from day 2. By the end of this, you should have had at least 2 questions that you have added to your list from the second day's lesson. Pause the video here if you need more time. So here is a sample driving question board from students in Miss Webb's class, and I'd like for you to see if any of these questions on this slide are similar to yours that you listed. So if you think any questions need to be added to your list, like maybe something from this list of questions makes you think of something to add to yours, go ahead and add that to your list. It's okay to have a lot of questions. That's how we find things out and learn more. Pause the video here if you need more time to add to your list and to look over this list of driving questions. When I did this with my class, we had a lot of questions about how hail forms and how temperature affects the solids and liquids and gases that are in the air and in the clouds and in that are falling to the ground. So make sure, again, that if you had more questions to add to your list that you are doing that. But now we've reached the last part of our anchoring phenomena routine, which is coming up with ideas for investigation. So find one last new space in your notebook and record the heading shown on this slide on your paper, which is ideas for investigations. Make a list of your ideas for how we could figure out this hail phenomenon and perhaps even our other related phenomena. What kinds of investigations could we do? What sources of data might be helpful as we try to answer the questions from our driving questions board? Take a few minutes, record your ideas in your notebook. If you need time, pause and press play when you're ready to continue. Here's a sample list of ideas for investigation from another class. Do you see anything in this list that's similar about ideas that you had? Your teacher and your classmates will have gathered ideas from class while you were gone. So be sure to share your ideas in case something that you came up with is not on their list. You might have ideas that no other student had, and that's really awesome. And it really could be the key to helping your class figure out how hailstorms happen and how other related phenomena also occur. We've now finished day 3 of our first lesson. Again, your teacher will have gathered questions and ideas for investigation from your classmates, so be sure to share your ideas with your teacher when you return to class. Again, you might have ideas that nobody else had, and that's really helpful in figuring things out in science. Remember, science is collaborative, and your ideas are important. I wish you luck as you and your classmates work to figure out this super interesting phenomenon.